Welcome. We are going to do 68, 69, and 70. So let's do it. When I look at 68, I immediately think y hat equals a plus bx. We now have two quantitative variables. That's a big deal because we can use one to predict another. But let's take a look at the question. So it looks like there's a linear relationship of some sort between number of chirps and air temperature. And I think this makes sense. So if you go outside, you hear the chirps, chirp, 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 chirp. And if the temperature changes, you might hear more chirps or less chirps. Well, we're recognizing that the slope is positive. So it sounds like the temperature and the chirping have a positive relationship. So let's figure out what they're asking. It says X is chirps, Y hat is estimated temperature. We can use one to estimate the other. What would you estimate would be the increased temp that would correspond with increase of 5 chirps? So let's break this down using some notes. If you missed this question, we want to write the formula. Y hat is equal to A plus BX. And we're going to, again, define Y hat as, just like they did, the estimated temp, because if we got this question free response, the estimated temp in degrees Fahrenheit. So that's what Y hat is. And X is the estimated, not really estimated. X is number of chirps per minute. Okay. So this is very important to the question because they're asking you to use the slope. They're asking you to use the slope because they're saying if any increase of 5 chirps happen, how would that affect the number? So any amount of increase in 5, that's my slope. So slope, or M. In this class, we always call that A. So slope is M. And again, in this class, we always call it A. Slope is equal to rise over run. So that helps us remember that slope is equal to the change in the Y over the change in the X. So it's a lot like a science class. So how much did Y change? Okay, so the temperature change. So they didn't tell us the temperature change. They'd like us to calculate that. So we are going to make X what we don't know. So they want you to calculate the temperature change, and I'm just going to call that X. I guess I could call it Y or any other variable. But I don't know the change in the Y, but I do know the change in the X. So how much change in Y would happen if we increased it by 5 chirps per minute? So I'm going to put a 5 there. And we also actually know the change in Y over X. We know it from the number right here, the slope. So the slope in this question is the number 3.3. So we actually know that for every 3.3 degrees Fahrenheit, so Y changes by degrees Fahrenheit. So we know that because of the slope, for every 3.3 degrees Fahrenheit, you're going to have 1 change in the X, or run. Well, the change in the X is 1 chirp per minute. So making sense of this, the slope is, no matter what, for every 1 chirp extra we get, we're going to get 33 more degrees Fahrenheit, because that's what that number slope means. So we can figure out, if I have 5, we just kind of cross multiply and solve, just like we did on an SAT prep question. X times 1 and 5 times 3.3, and that's how I get 16.5. Great job. Now let's take a look at the next question. It's statistical inference. We got an H sub O of mu equal 10 and an H sub A of mu is something greater than 10. You took a sample from a normal population and you got a mean of 13.4. So that's great. I'm just going to set this up. H sub O, mu is 10, H sub A, mu is greater than 10, and X, the X value we got was 13.4. So this is pretty handy because it looks like you have some amount of evidence that you got a value greater than 10. So we have to calculate a p-value, and they were really nice. They calculated it for you. So the probability of getting that outcome, if in fact the average was in fact 10, was really unlikely because that's way higher than 10. So you did collect some amount of evidence that would go toward sufficiency in figuring out whether or not the alternate hypothesis can be concluded. The p-value they got is 0.017. So since that is less than alpha, or 0.05, since that's less than alpha, you're excited because there is sufficient evidence to conclude H sub A. And what is H sub A? They told you H sub A was mu is greater than 10. So let's take a look. I'd add these words right here. It says, because since the p-value of 0.017 is less than 0.05, we do have sufficient evidence to conclude H sub A, which is that mu is something greater than 10, and that's exactly what A is saying. There is a sufficiency. There is reason to conclude mu is greater than 10. Sorry about that, Belle. Last question, 70. Oh boy, this is an Algebra 1 question. So let's take a look at some notes here. It says, given this question, which one would have a mean, that would be greater than the mean? So that's exactly what right skewed is. So make sure you take some notes. Let's not miss this one again. In right skewed data, that we call it right because the mean is pulled over to the right, and that would mean the mean is greater than the median. In this type of data, bimodal, two humps, the median and the mean, the left and the right would cancel each other out when you average them, and the number in the middle is in the middle as well, so both the median and the mean are in the same. This is uniform data, both median and mean are the same, and in normal distribution, median, mean are the same. This one's left skewed data, and then in less skewed, the median's pulled down or lower to the left. So lower to the left would mean the mean would be less. Thanks for joining.